All right. Well, thanks guys for waiting. Lost my power and now I'm back. So I think that was my power's way of saying I'm probably spending a little too much time talking about factories when I should be talking about object-oriented programming. So let's go ahead and we'll take a step away from this factory here where we were having fun with the this keyword, and we're going to jump into classes. Classes are really, really cool, okay? Because classes allow us to take that factory, if you will, and shove all the pieces together that we want, but it's easier to use and I have more flexibility when I want to use the pieces of this one in this one. Okay, and so what we've got is a class very similar to our JavaScript factory previously. The class is a JavaScript way of creating a blueprint. All the students are going to look like this, right? And so I can include everything that I need. Now the differences are, instead of being a function, I use a keyword class. And in addition to that, I'm going to also look at having a special function that that special function is called constructor. Constructor is every class has to have one. Okay, even if it doesn't do anything, it has to have a constructor. Now, the constructor can take in those parameters just like our function did before, and it adds them as attributes into this object. And every object is going to be referred to as an instance or an instance object. And so what you've got is you've got this class and it has a method. You'll notice this method looks very similar to what we had in the object, but now there's a slight difference, and that's the fact that this school here, or this function, is going to be shared by everybody. Everybody gets to use it. And so I don't know if you guys can hear that. Anyway, now we got fire trucks going by. Hey.
Oh no, no worries.
You know, we'll find out. Anyway, the crazy world that I live in, this huge metropolis. Anyway, this function, it only has to be created once in memory because this class, everybody shares it. I don't have to make a new copy of it for everybody. And the functionality, this if then else, else if is here, and it can apply to every single object that I ever create. And so I have everything that I need now in this class. And this class, just like before, I can create new students. And those new students, it looks very much the same, except I use this special keyword, new. It's very clear. This new object that's being returned by the student class is going to have these properties, Billy and 8 years old, and Sally and 16 years old. And each one of them gets saved off into its own object, just like our factory. The difference being, now I can start doing things that classes do. Because if all I needed was to create one single object and push it through a factory, I could use this factory version. But if I want to be able to do anything more than punch out that one widget, I want to be able to take something and learn from it and grow it. And, you know, like Antonio was saying earlier, he was talking about, hey, could we take a single book and turn it into, different classifications of books, different classes of books. Ooh, the fancy word, class. Yay! So now we understand there's lots of different ways to approach things in programming. Classes and objects is kind of like a big deal in many, many different ways. And it solves a lot of really important problems. But there's a place for functions, and there's a place for static objects, the object literals. There are places for factories, and there are places for the classes. So we're going to get into hierarchy, because one of the greatest things that we have is we have the ability to inherit things from another class. If this class is just a blueprint, and I have commonalities between this particular item and this particular item, then I can actually take advantage of that. So one of the things that you'll find whenever you search the internet, you'll always look at trying to group things in hierarchy. Now, just to help you understand, you can, in hierarchies, in class hierarchies, you're going to actually refer to things as parent and child, grandparent, grandchild. And so that kind of draws a picture in your mind, right? I mean, if I think of my grandparents, there were certain things that they passed down through my parents that came to me through genetics, maybe even through a will, I don't know. But it's going to be things that get passed down from person to person. Now, I still have my very own hazel eyes, right? And I've got my own brown hair, and it's not my parents. They still have their own. Grandparents, they had their own. So, I just kind of got things passed down to me. And in a class hierarchy, that's very similar. So let's look at just a kind of an idea of how this would work in the animal kingdom. An animal is a very broad thing, kind of like books in the library. All of them qualify as books, or animals in this case. And an animal can have a picture of the animal. You could keep in the programming, right? You can keep a picture. You can say what type of food they eat, if they're hungry, what their boundaries are, where they're normally located, and then the things that they do. So the things that describe them are up here in the attributes. Down here, you'll notice all of these methods. Because of the parentheses, these are all verbs. They're actions. They're things that they can do. And each one of them can do it a little differently, but they all make noise. They all eat. They all sleep. They all move in some way or another. And so we could make all of these things a single animal. But there's other ways to group things. We could make another group that was like this says, I wonder if a lion, tiger, and cat would have something in common. Well, I'm pretty sure they do. Wolf and dog are both canines. Maybe there's something that both classes could use. So what we start doing is we start breaking these things down, and we say, okay, what's the most common thing? And then let's take another subgroup and say, how do those have something in common? And so we start building our class hierarchy. So a child class of one parent can be the parent of another child. So we start seeing how these things are going to go from top to bottom. Okay, there is an animal at the top of this. And we can break those out into different groups, and we can say reptiles, birds, mammals. And each one of those can be broken out further. Snake, lizard are reptiles. Parrot is a bird. Horse and bat are mammals. Okay. Now we can see how these things kind of relate to each other. The trick is in programming, seeing what makes sense. We want to see how they match up. And I'll tell you that there's simple tests that can be used in order to look at these things. There's the is a. A snake is a reptile. A reptile is a animal. A parrot is not a reptile. A parrot is a bird. Okay, so if we take the time to break these classes out into their little subgroups, we can follow it all the way down. Now, if we group cats, this is another way of looking at it. We got the animal, and it's got these three methods. These three methods get shared among all three of the child classes. But there's different things about those child classes. You can see that a reptile will grow scales where a mammal will grow fur, and a bird grows feathers. If we take the mammal class down to a cat, we can say claw, right? Tigers, lions, panthers, they all claw things. So they get that special function, that method. And so when I get down to a lion is going to have a claw method. It's going to have a grow fur method, and it's going to have a eat, sleep, and breathe method. All five of these are found down in this class. So when I create a lion, I get all five. I inherit all five classes. All right? So, does that make sense? You guys hanging with that okay?
Yes.
Okay. I'm willing to go with it. So here goes everything. All right. Let's look at Fred the cat. Fred the cat is clear down at the bottom of my tree. He's down here. Fred is a type Felix Leo, which is of type Felix, which is of type cat, which is a carnivore, which is a mammal, which is a vertebrate, which is an animal, which is an organism. Now, here's a very important question for you to answer whenever you're programming something. Do I really need to have this many levels between myself and the top?
No.
Most of the time, the answer is no. Honestly, I'm not going to program the entire living organism spectrum. Okay? If I really just want to be talking about cats on my website, I may have a cat class that goes to indoor and outdoor. But that's about as far as I'm going to take it. I could tell you, I could add attributes about a desk that say how many scratches are on it. But more than likely, I don't need to keep track of that information. So every time I look at creating a class, I'm going to look at what do I need and why do I need it and how am I going to use it? Because that's going to tell me what the attributes are, as well as what am I going to do with this, the methods. So as a result, I think that it's probably best for us to try and get something that's a little more hands-on. So let's start with a school, okay? And more specifically, I want to know about the people in the school, okay? So I know that every type of person that's going to be in this school is going to have some commonalities. So let's create a person class. What types of things do we want to know about the people that are in the school?
First name, last name.
Okay, so I'm going to just, for space purposes, I'm going to say name. Is there anything else that we would want to know about every single person in the building?
Address.
We could do an address.
Grade level.
So a grade level would be perfect, but is that going to apply to teachers and office staff?
Oh, you're talking about person. Oh, I get you. I see what you're saying.
Yeah.
But I definitely agree, if it was a student,
Well,
it would be good to know what grade.
Are you talking about an elementary school or a junior high with, you know?
well, in that case, if you're going to be breaking it up like that, which makes a lot of sense, would you maybe call it like a level? Like you'd have staff, student, and like admin, or like, you could basically have like different access levels or different attribute levels.
Okay. Yeah, I mean, you definitely don't want the students having principal's access in the computer system, right? So we could say access level. Okay. And
Created
so,
that and updated that.
okay. So we could have like, we could have other things like, when they started at the school or things like that. We could also, let's think about what can every person do inside of the school. What would we want a computer program to do with every single person in the school? What do we want them to like be able to move rooms?
That's a good question. Because you already have access level, but
So we could say, like moving rooms. Where are they located at right now? Right? So we could have a location.
oh, location. Oh, okay, I see what you're saying.
Okay. So move rooms would be a method. And maybe we could print the information about this person. Right?
Mm-hmm.
So there's a couple of things that we could do with every person. Now that takes us down here, and if we look at students, that's a very specific type of person, right? And so similar to the drawings that we saw before, we could say, okay, this student, if it were to get all of this information from the person, automatically, I don't have to type that into my student class. I can just inherit all of this information, the methods and attributes that are in the parent. So what other things do we want to know about the student?
You're muted, Bob.
It doesn't, is he muted?
Yeah, he was talking and he's.
Oh, okay. So now you're unmuted.
I was thinking, well, you already have grade, but age is what I was thinking.
Okay. Perfect. Age. Maybe we could.
Their lunchtime or recess. I mean, it's not into the person, but do you think if the lunch, it would have to be in the parent or no?
You could have a lunchtime in the parent because your teachers and your office staff still need a lunch hour.
Yeah.
Right.
And the age would probably be in the parent too, if you think about it, because that's something that everybody would have in common, right?
Good thinking.
Yeah.
So we could put the age up there. Okay. So
thinking
maybe. Go ahead.
Oh, sorry. I was thinking like extracurricular, but then that could apply to any person now that I think about it. I'm trying to think of something that's unique for a student.
Well, what about a number of homework assignments?
Or classes taken.
Attention. Hey, you might need that.
So
It's true.
So detention, that could be a Boolean, right? Awesome. And a student, let's just go ahead and think about what they would do if we have a number of homework assignments. Maybe they could turn in a homework assignment.
Mhm.
Because we won't expect a teacher or office staff to do that.
Mhm.
Dog
Okay.
8 function.
What was that?
Dog 8 function.
Dog ate. Okay, I like that one. A dog ate homework, because we know that our teachers aren't going to use that one. At least we hope not. I'm sorry, Johnny, but my dog ate your homework. You're going to have to do it again.
Yeah, I bet that's happened before at least once.
Oh, I almost guarantee it. Okay. So what about other classes? What other classes do we have?
Teacher, and then how do you
Management.
call them? Admins or management? Yeah, exactly. Yeah, what Antonio said.
I happen to know they do like being called admins, just so that you know.
It sounds very
I-
sophisticated.
Custodial. Definitely need that.
Oh, hey, that's a good point. You can't. Yep. That's
And
very
nurse.
Okay, I'll just point out to you, I worked for school districts for about 9 years, and as a network admin, and the best friends you could make were the office secretary and the custodial guy.
Mhm.
Honest, you called them admins and you gave them respect, and you could go anywhere in the school. You could do anything. It was awesome. So a teacher, what types of things would be specific to a teacher?
number of students.
Perfect. Okay.
Classes taught.
Like subjects.
Yeah.
Okay. And that could be like an array, right?
Yes, it would. Mhm.
Okay.
What were you saying, Antonio?
Like what if management was looking at the teacher, how many PTA sessions have they had with their students' parents, I guess? If that
So like parent contacts.
yeah, or parent parent context, yeah. But in the sense
Okay.
that they've actually communicated with them, would that
Mhm.
is that
Yeah.
okay.
That'd be perfect. And in some ways that actually adds to a method. It would be like communicate with parents. And that one we could actually pass in a student's name, right? So we could record that parent contact had happened, with who, what day. I mean, we could kind of save all that sort of stuff in arrays and objects, right? And we can also assign homework.
Assigned attention.
And we can make a student there, and we can assign detention.
I have a
I love it.
question.
Mhm.
Assuming that a student, let's say, has a detention, that would mean that looking into the future, that would mean we'd have to implement that somewhere else. Like if the student can receive detention, that means that the teacher would have a performing function, right, of that. So that would automatically go there.
So yeah, what you've got is, see, we have this detention Boolean attribute.
Mm-hmm.
And so if I pass in the student to this assigned detention method by the teacher, I can actually say student dot detention equals true. And now I've assigned true to that student instance. The teacher gave it.
Would you be able to, for example, have an if statement? If student has 4 missing homeworks, then this would happen, or is that going too far into things? Is that
Conditional.
Absolutely. Absolutely. You could go ahead and in the assign homework, since you're looking at the student, you could say if student dot num homework assignments, I'm shortening here, is greater than 4, then student dot detention equals true. There you go.
Self-running. There we go.
I mean, it's
Automated.
I passed in the student object, and so the teacher can use it.
Mhm.
Right?
And you probably also want a statement that would determine like a time. So like, if detention equals true, then you like give it like, a time, and then you'd probably have that conditional reset to false after a certain amount of time.
There we go. So this is one of those times where we can see how these different methods can actually use instances of other classes, but it's built into those methods within the teacher class. They have the control to assign detention. They have the control to assign homework, and they can assign it specifically to individual students. All right, so now I've started in on this work a little bit right here. Okay, and so I've given it just some of the very basics. I've created a class that's a person class. Now, the interesting thing about a person class, it doesn't have all the information we need. It just has the common pieces that I want to share with other child classes. And as a result, it's referred to as an abstract class. We don't intend to ever go const this person equals new person. It's just here to make a central place to provide information to all the others. Okay? And so one of the things that we had talked about was, this dot address was one, right? And I'm not going to fill these in more than just empty quotes right now. But we had the name, the age, the address. We had some other things that we had put in there. I'm just going to go ahead. I took a quick screenshot of it actually before I got rid of it. So, all right, we're thinking about it. Oh, there we go. Name, address, access level, location. So we can say this dot access level equals 3. Don't know what that means, but this dot location equals class.
Would you maybe want to call the location like school location so it couldn't be confused for address for later?
Yeah. I mean, it just depends on everything that we're looking at doing, right?
Mm-hmm.
So school location would be, if I planned on having multiple locations, multiple classes that use location, it would probably be good to know that that's the school location versus the, their address. So,
Absolutely.
Mm-hmm.
Especially when you're building stuff later, it can be very confusing when you're like kind of tying things together.
Exactly. And so this person class, okay, as we look at our drawing, we can see that the person class is at the top, and we're going to pass down that information into the other places, right? It kind of gets freely inherited to all the children. And so a student is going to have all of these things, but I can make things special for the student in here. And the way that I do that is I come in, and the first thing that I do is I create my class. And that class is a student. Okay? And then the student itself is going to extends person, meaning start with this guy, give me everything that he has, and then we'll make a student out of that plus what we want. And so I'm going to do super, and inside of super, I'm going to pass in the name and the age. Now you'll see when I use the keyword super, it goes to the constructor for person. I'm actually using the constructor and making a person object first and bringing it down in here. And then I can, with that copy, I can now adjust it and add to it and do whatever I want. So here I do super, and it requires the person constructor requires a name and an age. Well, name and age were passed into my constructor here, so I'm just going to pass them along. And so now I've filled out this person object, and I can add in some additional information. And so here we had grade, detention, and number of homework assignments. And so grade equals, let's just say 8th grade. And detention starts out with a default of false. And let's see here, number of homework assignments. And that'll default to 0 because they're just barely getting created in the school. So they shouldn't have it yet, right? So.
A quick question. Why we are putting super here? Can't we say person, name, and age?
We could, but then what we would have is, instead of combining the two into a single object, we end up with an object that has a person object inside of it. So that would be.
I see. Got it. So if we do person here, it will be just a separate person. But if we use super will use person, and in combination add few more things for student.
That's right. And then I can refer to this dot name as the student's name, and I don't have to do the student dot person dot name. That's
Got it.
So it's allowing them to kind of mesh the two objects, the two classes together when I extend the person.
Got it.
So it's a great clarifying question, though.
Sure.
And so
if you have like a second, I just wanted to ask one quick thing about this. So this means the current instance, right? So if I don't use this, then basically I'm trying to change the value which I'm assigning by saying equal to, then I'm assigning that value into the object, but we are not doing it in the object. That since we are doing it in the instance, we are using this. Is that right?
yes, that's correct. Because if we don't use this keyword, it's not sure where it's supposed to go. The constructor is.
So basically, if we don't use this, it can basically go to the direct and change the value in the object for object itself, right?
Yes.
And if we are using this, then we are basically doing it in an instance, so that we can keep making different instance and assign different value to different instances.
That would be correct.
Got it. Thanks.
So
would you be able to add to the class person a default value to name and age if it isn't inputted into the system?
Yes,
I put it into the chat. Would it look something like that? I mean, I kind of misspelled class, but would it be something like that with a age number, or would that be in parentheses? I mean,
yeah, that's exactly right, actually. So we'll right here in our student, okay, the student, I gave a GPA.
Okay.
This is a default value, but if I were to pass a third parameter into the new creation, it will override what I put here, and it'll put in what got passed in with the creation.
Okay.
And so, yeah, this is a way of being able to override a default. And this is a default that is just set no matter what. No matter how many times I create things, I can't change this dot grade until I have the student created, and then I can change it. So two different ways of doing defaults. One can be overridden and one cannot. And so I actually have the note here. If you don't pass in something for GPA, it'll default to 4.0. If you do pass in a value for GPA, it'll use what's passed in. So.
And that passed in value will be on line 35.
So yes, on 35, it will use the passed in value, but this, by giving it a default up here, if they didn't specify a GPA, well, then this is still set as 4.0. If they passed in GPA as, 3.2, then it would take that new value in this variable and put it there.
Got it. Thanks.
Yep. Awesome. We're moving right along. So now in our objects that we were talking about earlier, we have that get school level function that I just copied right in. And so I'm going to have that one. And then let's just create I'm going to create one more. Gonna create one more thing here. I just got to get my notes back up, because I was doing things just a little bit different here. And so, but I'm gonna fill out another method here for turn in assignment. And I don't have to have any parameters because everything that I need is inside of this object already. And so it would be this dot number of homework assignments, and I could just do a minus minus, because that number of homework assignments that are due, if I turn it in, it goes down by one, right?
Mm-hmm.
And so I am going to just say console.log, and I'm going to use backticks here so that I can use some inline work. So this dot name, because this student has a name from up here, right? This dot name just turned in an assignment and now has this dot number of homework Am I spelling that right? Why is it not auto-completing? Remaining. All right. So now I can just say, I'm going to work with this. The student has the ability to turn in assignments, but the teacher doesn't. And so that's where a student can differ from a teacher. So now the things that are unique about a teacher, right? We had talked about they could have a number of students, they can have an array of subjects, they can have parent contacts. We can have different methods, assigning homework, assigning detention. We can do communicating with parents. So let's go ahead and let's just add in a subject that they're teaching, and I'm not going to make it an actual array. I'm just going to make it simple on myself. And so this dot subject equals subject, so that we can have that. Here again, I used a default. so that if they didn't provide anything, it just says all subjects, but otherwise it can be what we want it. And then in here, I'm going to give, let's see here, assign homework, right? And that one, if we take in a student, we have the ability to increase the number of homework assignments that that student has. And the way we do that is we refer to the student and we say that student has a number of homework assignments and I'm going to increase it. Everybody's favorite thing, right? And we can say console.log and this.name. So this teacher's name just assigned homework to student.name. So you'll notice how I'm referring to the student object that got passed in again. And so now they now have student.number of homework assignments left. There we go. That looks good, right? And then we can assign detention because I like that one. I'm sure the students don't, but giving that permission, that's just wow. So we take the student and we say has detention or detention. Ooh, don't want that one. Student.detention equals true, right? And we can say if student.num homework assignments is greater than 4, then this dot assign detention. Pass in the student. So the this is in reference to this object's assigned detention. All right. And so we can assign detention to that student, passing the student over to the other method and make that change, right? I think what I may do is just to make things look nicer. And up here, I need to close this guy out. Okay. And we're going to console.log here that this student.name now has detention. All right. We are going long here. All right. So this student has detention now if they've gotten into that. So let's just go in and we're going to create just a couple of things. We're going to do const student1 equals new student. We're going to pass in Billy and his age is 16. And we're going to create a student2 that's a new student. This one's Sally, and Sally is age 15 with a 3.7. Billy's probably more likely the one with the 3.7. Sally's got a 4.0, I know that one. And then we also have to create a teacher. So teacher1 is a new teacher. And that teacher is going to require a name, age, and any subject that we want. And so we say Mr. Homework is his name. And he is 45 years old and he teaches math, everybody's favorite subject. So now we know that the teacher can assign homework, right? And so if we say teacher1 dot assign homework to student 1, and then let's just go ahead and make a few of these here. We're going to replace this with 2. Whoops, no, just kidding. Teacher 1, we need to replace this with 2. And so now we've got a situation where student 2 is getting a lot of homework, right? And then just for fun, because I always love to console log things, let's console log student 2 so that we can look at that one. All right, is everybody ready to try this?
All right.
Let's see what we got going here. Okay, so node school JS, and let's look at what happened here. Okay, so Mr. Homework just assigned homework to Billy, and then Sally's getting leveled up here. She's getting 4 homework assignments. Poor girl. Now here's the cool thing. When I console log this object, this class object, it tells me what class it comes from. And then it shows me all the pieces and parts that belong to it. So get school level is a function that's included in this object. Our class has basically taken our objects and made it available to us, right? And so all the things that came from the person as well as from the specific student class are here. We can see that Mr. Homework has assigned things, and I'm sorry, Sally, but I think I'm going to have to add one more homework assignment to you and see what happens. And we also need to have student 2 start turning in assignments, right? So let's go ahead and let student 2, oops. Let's student 2 do a few turned in assignments and see what happens to the setup here. Okay, so Sally ended up with detention because she had 5 assignments, but that was really unfair to make it based on 4 because she's got 8 classes a day. So, you know, we may have to adjust our program based on these things, but then Sally was able to turn in a few assignments, and we can see that her object now has only 2 assignments left. We have the ability to, in our code, instead of having to put all this information into every single one of my classes, which would be the way we did it in our factory approach, we'd have to copy and paste all these attributes and methods into every single object factory that we created. But if I can use something central up higher that everybody below it gets, well, then I've saved myself a whole lot of coding. And if I needed to add one more thing, maybe I needed to add in something like to my person class, this dot is vegan, right? Well, I've just added that to every single class. The student, the teacher, and the office admins all have that brand new attribute added to them. And so that is a super cool thing. Now, I know this is kind of crazy, but does it make sense?
It does. I have a question after everyone has their question. It's a little off topic, but it's about destructuring.
Okay, so let's go ahead and cover the destructuring at the end. Yeah.
Sure.
Perfect. All right.
I have a question about the super attribute.
Okay.
Now,
The super method. Yeah.
Oh, sorry, super method, excuse me.
Uh-huh.
In this case, when you're first referring to it with student, why are you only including name and age? Is that because that's like kind of the one element that is then passed? I get that it refers to it based on the parent class student, but I just am confused as to what super's role plays relative to what you enter into the super method.
That's a great question. So the super method here is another way of, it's another way of saying, use this constructor. My parents' constructor is what I need to match with super.
Okay, now why wouldn't you put all the attributes in there? Why would you only include those two? Is it because you're kind of limiting it when you are calling it in terminal? Then it will just show, like if you reference like a specific, like student 1, student 2, like a certain ID, it will only show up with those 2 key attributes, and it's easier to recognize it because you'll have like a very small piece of data as opposed to every piece of data for that individual. Or
Well, what we've got is, let me see if I can get it onto the screen here. Okay, actually, if I hide that guy, I can get it in here. Okay, so what's actually happening here is super, it refers to person, okay? And so super is going to look at the person class, and then it's going to use the constructor. So this constructor requires 2 parameters in order for the constructor to work. And so the reason I only sent in these 2 arguments is because I needed to match those parameters for the constructor for the person. And so the super is saying, okay, I'm going to create a person object first. And that's why super, just so that you know, has to be the very first line if you're extending a class. Super is going to just say, okay, I go up to that other class and I grab its constructor. Now, the funny thing is if person was a child to something else, it could have super in it. And its super call, that super method call, is going to go up to its parent and use its parent's constructor. If we look at the teacher, okay, notice how it extends the person class as well, and its super is trying to go up to the person constructor. And it only has a name and age because that's what the constructor up here is looking for.
okay,
Does that make sense?
yes, I do follow that.
Okay.
So if you were to be making a robust application, would you want it to refer to everything? Like, would you want the constructor to include every attribute if it was all mandatory?
So if all of these attributes in the person class were mandatory and I had to, if I needed to have information passed in for every one of those,
Yes.
then yes, I would add in parameters. I would add in an address,
Oh, good. Okay.
and
Yeah,
I would
that's what
add in a access level.
Yes, got you.
Could you
So-
use REST?
Could I use what?
REST in there instead of doing it manually? Let's say if you had so much things in there, could you just use the, what is it, the REST operator, or the, what is it, spread, or whatever that is? So you just
So-
grab everything possible?
Well, it just depends, because if you had a single parameter that held all of the person's attributes in it, then I could use different rest and spread and things like that to manipulate it. But typically your constructor will take in the individual pieces so that you can easily assign this dot name to name and this dot age, instead of having to go, if I had params as an array that came in, then this dot name
Oh.
would be params one,
complicated.
you know? And so it doesn't buy me a whole lot to try and combine those together, but you can do it.
That's a good
It's absolutely
question.
legit.
Okay.
Okay. Go for it.
And then the last part of that is, so if you are to be adding all those attributes and they all are mandatory and you want to be tracking that across multiple different methods and blah, 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 and classes, would you then be including that in the super as well? Because it would be then referring to it, correct? So then your super list would basically be a copy paste of that constructor field. So the constructor can be whatever it is that's defined in the new class, but then the super then grows proportional to what is in that class.
That's right.
The parent class.
So if I added address and access level to the parameters, then I would have to have an address and access level down here. And the nice thing is a student, right? A student could have passed in just for here, I could have an address, right? But then I could make it so that it just goes in as student. I could manually configure that access level without passing in a variable.
Oh, interesting. Oh, okay.
Okay. So, I mean, I'm just, so if I just said, you know, let's see here, let's just do role, right? Here, I could do student, right? And down here on teacher, I could add in teacher.
Oh, I get you. Oh, that's smart. Yeah. That makes sense. You pull from the array specifically based on the role.
But I have to match the parameters of that constructor. If it requires 3 things, I have to pass 3 things.
Yes.
Yep. What was the question?
How would you be able to add just a note for anyone that's able to be edited? Would that be something you can do? Like, if you wanted to add something that's not in whatever whatever the person class is, if you wanted to just add like a note or something that can be editable, like you can write anything in there, is that possible to do? What would you do for that?
Well, I would just go ahead and add to my constructor like note. Oops.
And it'll just, okay.
Because I mean, I can make that whatever I want, right? So a note, and then I would just add in this dot note equals note, right?
Okay.
And then you just so that you know, anytime you do optional parameters, they always have to be the last parameters, because the only way a method knows to match things up is the first thing that got passed in goes to the first parameter, the second thing that got passed in goes to the second parameter, the third. And so if I wanted to skip something, it has no way of knowing that I skipped it.
Okay.
Right? So that's why optionals are always at the end. And, you know, just make sure that they have a value you want as a default.
Okay.
So, all right. Any other questions?
Thank you for explaining that. That was very helpful.
One quick one here is,
After her.
so if I'm passing values, just give me 1 second.
Go ahead, Antonio.
Okay, so let's say we wanted to grab each of the students' GPA. I already know how to accumulate the average, but how would we grab all of the students' data? Let's say we had Sally, Megan, and Billy. Just grab their GPAs. And I know it's pretty self-explanatory to get the average GPA of your students. But how would you grab those?
Well, what you have to do is you have to somehow associate the students with the teacher. So the teacher would have like an array of student objects, right? And then the teacher wanting to get an average would have a method and it would say get average, and it would iterate through that entire array of student objects
Okay.
and create the that average just doing the math.
Okay.
So my
Alright.
question was,
Yes.
the student attributes are there, right? What will happen to the attributes which are there in the person, but they are not defined uh, as an parameter in the constructor? Like, for example, if you move up a little bit, person, yeah. So now we have name, age, role, and node. But what will happen to address? Will address be there for student, or it will not be there?
It will be there. So the thing is we made address just an empty string by default. So when we create a student, it's still going to have a this dot address, an address attribute, but it'll be an empty string. And so to change that, I would just say student2 dot address.
So what I wanted to know is, whatever parameters we define in the constructor signature, um, doesn't matter if we have more attributes in the body. When we make extend and make a copy like a student or something, that will still have all of the other attributes which are not there in the signature.
That is absolutely correct. Ah, good question. Okay, so \n, that is, it's a new line. We're just adding an extra space here, so that when I call print, it's gonna give a blank line and then print out my console log. So that's a great question. And I'll at places I also use a \t, which is a tab, and that indents the output. So right here, a \t. You can see that right here in the output. Mr. Homework just assigned homework to Sally, which is here. And then I indent, I tab in on my console. And that's just, I'm a big fan of using console logs to keep track of things. And so I can organize my output by putting tabs and extra lines in, so it's easier to read. Because sometimes when you get down here and you see everything just kind of merging together, it's kind of hard to see it unless you have that tab in place, right? And so, what was that?
What would that be called? It's not, obviously it's not regex, of course not, but it reminds me of that kind of.
Yeah, it's called an escape sequence or escape characters.
Okay.
Mm-hmm. Great questions. Okay, so now we're running really long. Part of that is because of the power outage, but I'm going to jump ahead and kind of use my completed versions for the remainder of things that we're going to look at tonight, so that I'm not typing and taking longer than we need to. So as you can see, I had created, previous to this, I had created a school project that had a person, a student, and they had a turn-in assignment, right? You can see teachers prepare lessons. What can I say? Another thing that we didn't cover, here is an override. Now, the way this works is my parent has got a method called print. And because it's my parent, I automatically get my very own copy of that same method. But say I wanted it to look different. I didn't want to accept the person version of print. I wanted to create my very own for this class. Well, the way to do that is you just create a method that looks the exact same, print. And instead, I can put in whatever I want for print. And then when I call that teacher's print method, instead of getting the one from the parent, I have my very own copy that I made special for this class. I override what was given to me. That's why it's called an override method. Now, seeing some kind of looks like, what? So, does it make sense, or is it kind of confusing here?
It makes sense. And just one, is it true that we have to keep the name and signature and parameters same? We can only change whatever is there in the body.
That is correct for JavaScript. So, it's a great question. We need to make sure that this looks just like our parent, but then I can change whatever's inside of it. So I can override a method with my own special implementation. And that's a really important thing about object-oriented programming. So we have the encapsulation where we're putting everything together into a single package. It's a blueprint called a class. And each instance keeps its own stuff. Now, we look at abstraction is one of the next key elements of object-oriented programming. Abstraction means I don't need to know how you do it. I just need to know if I say this teacher assigns homework, that student's going to get another homework assignment. I don't care how you do it. I need you to work the way that you tell me. And so that's abstraction. We're removing the complexity of how it works away from you. Most people don't know how an internal combustion engine in a car works, but they do know if I push on the little vertical pedal on the right, it goes faster. And if I push on the pedal on the left, it stops. And, there may be other pedals, but I know how to use them. I don't care how the inside of the engine's working. It's just, I push on the gas and it goes. I assign a homework assignment, the kid gets a homework assignment. It just has to do what it's doing. So abstraction, encapsulation, inheritance, that ability to inherit things from up above to come down. And polymorphism is another thing that is involved with object-oriented. You'll see that it's one of the 4 pillars, as they call it. Polymorphism is another way of saying many different forms. And a subclass can actually change things to be its own unique behavior, right? Like this, I can override and say, my print statement's better than your print statement, neener, 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 right? And it's because I completely changed it around. I made it my own thing, right? And so the 4 pillars of object-oriented, the things that make it the most valuable is encapsulation, abstraction, inheritance, and then fancy word polymorphism. All right. Now, another cool thing is when I look at all this work, it's quite a bit of typing. And every time I go to do something, I have to grab the object, and then I need to go off to its method and come back and then move down, and I got to grab the exact same object again, and I got to go and do this and come back, and I got to grab the exact same object and I got to do something else. Well, that's actually a performance hit. Not really a big one, but it is. Because you're having to pick up objects and put them down, and pick up objects and put them down. There's a thing called chaining. And chaining is actually very, very simple. Okay? It sounds fancy, but it's not hard. All you do is you add in a line at the end of your method. Return this. If we think about our lines down here, oops, that one's the chaining one. think about these lines. I'm using the exact same object. So here's my teacher 2, teacher 2, teacher 2, teacher 2, right? I've got teacher 2 all over the place. I got student 2 all over the place. And if I'm going to use the exact same object over and over again, like in this case where I use teacher 3 times in a row, if I were to return this, what happens is it's the same as saying, okay, I'm going to go and do this work first. I'm going to print. And then using the same teacher 2 object, I'm going to assign some homework. And then I'm going to assign some more homework to a different student. Then I'm going to go back and say, I really didn't like student 2, so he got an extra homework assignment for talking back to me, right? And it's all with the exact same object. Now, the reason this is important, this idea of chaining our methods where we can put them one after the other, it comes from first being able to return the exact same object we started with. This is the word we use, but it's also going to be very, very needed in React. We're going to use it all over the place. And so this is what you're going to do. Return this, and you have an easy way to chain things because it just puts teacher 2 back in the place. This gets done, it gets replaced with teacher 2, and it's like teacher 2 dot assign homework. Okay? So does that make sense for chaining?
Yes. Could you scroll up to the top real quick just for the end of that method or the end of that class? Okay.
So, and you'll notice my get school level returns this, and turn in assignment, return this, and assign homework, return this, and print, return this. Each one of the methods returns this, and because it does, it can be chained. If I were to have a method that did not return the this pointer, I cannot chain after it. So if my get school level didn't return this, I cannot go to the next one. It will error out on me. Each one of these, every single one has to return the this pointer. All right? Sweet. Okay. Let's just go for it. If you guys need to leave, feel free. I'm going to go through this as quick as I can. It shouldn't take too much longer, hopefully about 10 minutes, but I always think that I'm going to be faster than I actually am.
No worries. You're being really thorough. This is helpful.
All right. So callback functions. Okay. We know that we can assign a function to a variable name, right? And if I use that function, if I use that variable name with parentheses, it's going to execute that function. Well, we take that just to the next level up. A callback is we're going to do this function when something else is done. Okay, and the way it works is I go ahead and I can pass around a function like it's a variable. And so let's look at these. I've created two different functions, one to display the results and another to verbosely display the results. The console log shows more information, right? And then I have two different math functions. I've got an add function and a square function. Now, these functions, add is going to take two numbers and add them together. But then I can pass in a function name and say, run that guy. And so what I do is I do my normal math, But now I use my callback function with parentheses to execute it. And I can pass in this sum that I just calculated. Now, the cool thing here is I have two different ways of displaying things. I don't want to have to create two different add functions to display them. So what I can do is I can call the add function and I can say, here is the callback function I want you to use to display things. And so this guy, I pass in display results, right? And if I pass in display results up to my add function, my callback function then becomes display results. And it passes in sum. And if I wanted to pass in verbose display results as my function, it comes in, and that didn't turn out nice. There we go. It comes in, and the callback function now becomes verbose display results. All right. So I can pass around functions as parameters, and I can also make this callback function, because I could make this where, you know, an on-click event, I'm wanting it to do something, right? And I want it to have an arrow function. And this one's going to be give homework. And so now what happens is when somebody clicks on that button, I'm going to give some homework. And it's all because this is capable of holding an entire function. And that same thing, I could have a different button that does give homework as well. I could have give homework on 6 different screens, and the teacher could just hit it and it's done. And it's all using that same copy of the function that I created once. I don't have to copy and paste this way. So, just so that we can see this guy in action, I'm going to go ahead and CD over to 0. Oh, I'm in the wrong place. No, I'm not. ./05. This is where it's nice that I'm in the right place. Never mind.
Yeah, you're good. You're good.
So here, the add function, I passed in 2 different methods, one to display verbose and one to display regular. The square function was the exact same thing. I'm using this callback function parameter, and I'm actually passing in a function saying, when you're done with your work, run this guy. And so that's a callback function. All right. Any questions about that?
Would that be like similar to a promise?
It is.
Right.
It is actually. It's very
Right.
similar.
But the only
So
thing, promise would, no matter what, do this. Like that's what it would be, right?
yeah. So what's going to happen is when we get done with this promise, right? So a promise would be like going out and getting data from a server.
Okay.
When it comes back, that promise said, hey, we're going to give you stuff eventually.
Yeah.
It's going to come back and say, Okay, now that we're done, what did you want me to do with this? Oh, you gave me a callback function. I'm going to go ahead and use that stuff you gave me, or that I just got back, inside of that callback function. So, yep, that's actually exactly where we're going to be doing it. So, pinky promise, we'll do it. All right, so now, real quick, we have talked about all sorts of different types of for loops, right? There is a special one in ES6 called .map and even .filter. Now, .map is going to, just like all the other for loops that we've done before, it's going to go through and it's going to take this array, the Pokemon array that I created here, and it's going to go through each one of these lines, each one of these elements, one at a time. And each one will become this very first variable. And in addition, I'm going to get the index inside of the array where that piece of information is. And it's going to pass those two pieces of information into this anonymous function and run it for every single element in the array. So here I have an array of objects, and each object has a name and a URL. So this whole thing right here, this whole object is going to become PokeObject. And once it gets done with this code, it's going to come back and it's going to take the next element in the array and make it PokeObject and update the index. So it's just like a for loop. It's going to go through every element and allow you to do something, the exact same something, with every single element. As a result, map is only available on arrays. You can't run it on an object. Map is for arrays. And in this situation, I told it, I just want to print out the name and the index, right? So if I come into my terminal and I go into this folder and I say node map.js, it's gone ahead and gone through every element of that array and given me my name is the name and I am index, and it gives me the index. Very cool, right? Map is just a fancy way of for looping. Now we move over to the next type of thing that runs on our arrays. Same array as before. It's an array of objects. Now, filter, this one is still going to be like a for loop. It's going to go through and it's going to look at every single element in the array. But the difference is filter is going to create a brand new copy of an array, and it's only going to add in the elements that pass the test. Okay? So if I return true, then this PokeObject, this element in the array, is going to get added to a new array called filter Pokemon. And so if I say that I'm going to only grab your index if you're greater than 15, well, the first 15 of these Pokemon, technically 16, are going to return false. And so they won't show up in the new array. Then what I'm going to do is I'm going to use my new map function to iterate through all the elements that are now in my new filtered Pokemon list and give you the name and index of those ones. So let's go ahead and save that guy. Come down here and I'm going to do node for filter.js. All right.
Oh, did you not
So-
save it when you called it because you changed it to 15, right? Or
Yeah, I saved it after that.
oh,
When I changed the 15, I had to save it.
oh,
So,
okay. Huh.
but here's my command and the output. It's just this little tiny section here.
Oh, got you.
Okay. So as a result, my brand new array has got only 4 elements. And you'll notice that if we look at it, we had to be above 15. So Pidgey is 15 and he's not greater than 15. So we stop, we don't give him, but 16, 17, 18, and 19 are all there. And they all pass that criteria. They return true here. So they actually get added to this filtered list, this filtered array. If it returns true, it's added. If it returns false, it's skipped. And so this is a way of making a copy of an existing array, but making it filter based on your own criteria. Map doesn't care. It's like I'm going from start to end and I'm doing whatever you told me to on every single one of them.
Like if you were to make if you were to apply it to the model that we had made earlier, like if their GPA is greater than 3.8, you could have your star students are, and then print out the list kind of deal. Like you
That's
apply
Yeah, if your student array, you could totally do this and create a brand new array of your star students. Yep, perfect. So that's what I've got for you tonight. Any questions? All right. I promise my future lectures shouldn't take this long. But,
no, this was awesome. This was very helpful.
It's important for us to be able to understand these things so that when you go running off into those assignments, you're not going, what is this stuff? Kevin didn't mention this. So.
No, this is fantastic. Thank you for being so thorough. Like you really explain things well. It's very, very helpful and very easy to follow. So thank you for being, this is very well laid out. Thank you.
I feel like we owe you an app after all of this.
That was supposed to be that was supposed to be a surprise, Antonio. We were going to surprise you.
What can I say? I'm here to help. So any way I can teach and make it make sense. That's what I'm looking for. So
I have a question. When you were working at HP or just in your career, did you have headaches daily? Like what would you do? Like if you have no, seriously, because I code more than 8 hours a day. How did you deal with that?
That's a good question.
You know?
You get used to coding, your brain hurts less. But the truth is, quite literally, get up and walk.
Mm-hmm.
Yeah.
I mean, most programmers will actually get it through their neck and shoulders, and it'll just be, it'll actually create tension headaches. And so every half hour or hour, set a reminder on your phone or something that it pings you, and you're kind of like, okay, in 2 seconds, I'm going to finish this up, and now I'm going to get up and walk around. Right?
Now I see why a lot of the positions have fun games and ping pong tables. I think I noticed that.
There is a lot of that. If you get into the right place, you'll have some really cool perks. Yeah. But they also don't want to see you over there too often, or too long, I should say. So, yeah.
I'd recommend one of these, especially if you're having a really hard time, just to get that energy out, and also just to keep your wrists kind of moving, have a dumbbell or do something to kind of exercise your forearms. I changed
my mouse. That made a really big deal too. Mm-hmm. I had a magic mouse, and then I'll use a kettlebell and stuff. But I do take walks. I just want to know if I keep taking leaves every day, that's unhealthy. What do I need to do? You know what I mean? I want to find out another way. But okay.
Yeah, well, I mean, there's all sorts of things For example, for me, I've got a standing desk.
Oh,
So-
you've been standing this whole time?
Nope, I just barely stood up right now.
Oh, okay. I
So-
was like, dang, that's good.
But I mean, I've got a desk here that allows me to stand. I'm going to stop the recording here.
Oh gosh.
I-